Hi, 607 and 608. Today we are continuing to work on the learning target. I can calculate the volume of a right rectangular prism with whole number or fractional dimensions. Today's lesson is going to focus on determining a missing dimension if we know the volume already and two dimensions of the prism. So remember, a 3D figure has three dimensions. So let's review what we've been working on. When we're calculating volume, we're trying to determine the amount of three-dimensional space that an object occupies. Volume is measured in cubic units, which means the exponent is going to be the number 3. Just keep in mind a cube is a 3D square, which makes it a little special because a square has all equal sides. A cube also has all equal sides. And when we're calculating the volume of a rectangular prism, we're using the formula volume is equal to length times width times height. So here's an example. We have our dimensions, 5 centimeters, 4 centimeters, 8 centimeters. Remember, multiplication, the order will not matter. So as long as we're multiplying the three dimensions together, we'll be good. So here we plugged in 8 as the length, 5 as the width, 4 as the height. We start with 8 times 5, we get 40. 40 times 4 is 160 centimeters cubed. So now, what if we already knew the volume, and it was 160 cubic centimeters? The width was 5 centimeters, and we knew that the height was 4 centimeters, but we didn't know the length. Could we figure it out? Luckily, we've done lots of fun algebra before the school's closed, and we can figure it out. So, if we know the volume is 160 centimeters cubed, we know two of the dimensions, 5 centimeters, 4 centimeters, and then this unknown x centimeters. What we would do would be to plug in what we know. So we don't know the length, that's x. The width is 5, the height is 4, and the volume is 160. So now when we substitute in, we're plugging in what we know. So we know V for volume is 160, the length is x, the width is 5, and the height is 4. So now I can multiply 5 times 4, I get 20. I bring down what I have left. X, 20 looks weird, so I flipped it around. For a Jazz Hands ticket, what property is it? All right, you guys still aren't here. Miss you. It is the commutative property. Tells me that I can flip-flop x times 20 and write it as 20 times x. So I did that to make my life easier. It looks more what I'm used to when it's written 20 times x. I get rid of the 20. I can cancel out a 0 top and bottom because now I'm doing inverse operations here. 16 divided by 2 is 8, so the length is 8 centimeters, which matches our original example. So if we know the volume and 2 out of the 3 dimensions, we should substitute in the 2 dimensions that we know and the volume for V. Then we're going to multiply the 2 dimensions we know and then divide the volume by the product of the 2 known dimensions. The quotient, which is the answer in our division equation, is equal to the missing dimension. Miss Maljevic, can you please do the example?
Hi, 607 and 608. Today we are going to find the missing dimension of a rectangular prism using the volume formula. So here we have a rectangular prism, okay, and let's identify our dimensions here. So in green, I'm going to highlight this part for us. 8 inches is going to be our length. And I'm going to take the orange. 5 inches is going to be our width. And, oh, it looks like we're missing a dimension. Oh, yep, we're missing our height. So, in this case, we are given the length and the width. We're also given the volume. So the entire volume the entire volume, the space that this rectangular prism takes up, is 280 inches cubed. And it gives us the length and the width, and we need to find what the height is. So we're going to use the formula that we've been using, which is value equals length times width times height. Now we're going to substitute. Guys, we really need you guys to think and try to solve this question as if it's an algebraic equation. So let's substitute what we know, and let's solve for the height the way we would solve for an equation in Unit 5. So let's substitute what we know. I'm going to substitute my volume because it says that the volume is, it gives us the volume, 280. So I'm going to write 280 inches cubed. And I'm going to substitute 8 inches for my length. And I'm going to substitute 5 inches for my width. And then I'm just going to leave my h, because my h is my unknown. We don't know what the height is. So now I'm going to rewrite this. So 280 equals 8 times 5 times h. In this case, I can definitely multiply 8 times 5, right, and get 40, right? 8 times 5 and get 40, but then I also have to multiply h. So I'm going to bring my h down, right? Equals 280. So now, think about here, we have 40h. What operation is happening to 40, right? What operation is happening to 40? It's multiplication. We are multiplying. That's what the formula is for volume. We're multiplying. So, what operation undoes multiplication? It's division. So we're going to divide by 40. Divide 40 by both sides. So divide 40 by 40, that cancels out, and you're left with h. Remember, we have to isolate the variable, which in this case is h, because we want to find out what the height is. So you have 280 divided by 40. We have a 0 and a 0. Use the trick that we showed you guys in class. So you're left with 28 over 40. 28, over 4. So 4 times what other factor is going to give us 28? And you're going to see that h, which is the height equals 7 inches. And no, we are not cubing the 7 inches because it asked us to find a dimension. It did not ask us to find the value. When you multiply the length, the width, and the height, then you cube your answer. In this case, it asked us to find the missing dimension, which was the height. So we are not cubing our dimension.